Today we're going to be looking at another way to display data. A box plot is a visual representation of data split into quarters. Remember, quarters are 25% or fourths. It gives a 5-number summary of the data when it is ordered from least to greatest, called the measures of variation. So up till now, you've heard about what's called the measures of central tendency, which is the mean, median, mode, and range. The measures of variation are the minimum number, lower quartile, median number, upper quartile, and maximum number. The lower quartile is the median of the first half of the data, and the upper quartile is the median of the second half of the data. So if you're looking at a box plot, which we see here, when you draw it, this number here is your lowest number or minimum. This here is what we call the lower quartile, which is usually represented by Q1. This here is the median. This here is the upper quartile, or Q3. And this here is the highest value, or maximum. And just like when we looked at histograms, the box plot also shows the distribution of the data. So when we're talking distribution, the data is negatively skewed if the left line is longer than the right and the median is closer to the right. Okay, so in this case, if we're looking at this median is way over here on this side, and then we have a tail, kind of like in our histogram. So this kind of acts as the tail. So these numbers down here are going to pull the median down, making it negatively skewed. Then the data is symmetric if the lines are the same length and the median is in the middle, as shown at the very top diagram. If the median is close to the middle and both sides are pretty much the same on either side of the median, we call it symmetric. And the data is positively skewed if the right line is longer than the left and the median is closer to the left. So in this case here, the median is close to the left. So that's going to show that most of the data is very close here, where these numbers are more spread out, creating a tail, and also pulling the mean up. So the median, again, would be more representative. All right, so again, there is a way to have your calculator help you set this up. So we have Lucas is going to college in either Dallas or Nashville. He wants to live in the warmer of the two. Create a double box plot of the data and compare. All right, so we have to come up with our measures of variation for both of the sets of data. So for Dallas, we're going to enter our numbers and pull it up on our calculator by going to Stat and Edit and our L1. We're going to clear list 1 if you already have data in there from yesterday by going up to L1, hitting clear, and pressing enter. And then entering the Dallas temperatures. So we have 36, enter, 41, enter, 49, enter, 56, 65. Oh, and I misnumbered my 65. 73, 77. When you're doing this, it's really important that you don't mess up a number or miss a number. 76, 69, 58, 47, and 39. And I should have 12 values, and I do because there are 12 months. So now I'm going to go to Stat, I'm going to go to Calc, and I'm going to pull up my one variable statistics again, enter, and enter all the way down. And now I have my 5-number summary. If I scroll down, I have my minimum value all the way to my maximum value. Those numbers there are the measures of central tendency. So our minimum is 36. Our quartile 1 is 44. Remember, that's the median of the lower half. Our median is 57. Quartile 3 is 71, and that's the median of the upper half, and our maximum is 77. So now I'm going to do the same for Nashville. I'm going to go back into my stat and edit and clear and enter the temperatures for Nashville. So we have 28, 31, 39, 47, 57, 65, 70, 68, 61, 49, 40, and 32. Go back to stat, go back to calc, one variable statistics, enter all the way down. And we have, again, our 5-number summary, which is our measures of variation. So we know that the minimum for Nashville is 28. Quartile 1 is 35.5. The median is 48. Quartile 3 is 63. And the maximum is 70. All right, so now using those numbers, we are going to create our double box plot. All right, so we need to first make a number line. So at the very bottom, I'm going to draw a line. And then I'm going to decide, well, I know that my lowest number is 28 and my highest number is 77. So I'm going to think about how I could split this up. So maybe I go by 5 starting at 25. So 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. And that's pretty much all that we really need there. I only got to go to 77, so I can go a little bit past that 75. All right, now we're going to draw both of our box plots. So I'm going to have Dallas in green and Nashville in blue. When you're doing it, you're going to label them so that it's obvious which one is which. So starting with Dallas, I'll put that on the bottom. We start at 36, so a little bit past 35. We put a dot, and then that's going to bring us to 44 for the first quartile. So that's 25% of our data right there. Then all the way over to 57. So we have half the data now graphed, and this box represents another 25% of the data. Then over to 71. There's another 25% of the data. And then over to 77, another 25% of the data. So you can see in this last 25%, that means the numbers or the temperatures in that part are squished together. It's not that there's more, it's just that they're closer together because each part represents 25%. So this is 25%, this is 25%, this is 25%, and this is 25%. It's just the spread of the data inside each of those intervals. Okay, and I'm going to label that Dallas. And then I'm going to go ahead and do Nashville. So for Nashville, again, we start at 28. Then we go over to 35.5. That's our quartile 1, our first 25%. Then we go over to 48. Quartile 2, and our next 25%, and our median. Then over to 63. So we have a pretty large spread in this 25%. And then to 70 for our last 25%. Done. Okay, so now we have our box plot, our representations of the temperature in both of those areas, and we have to compare the data. So we could say Lucas should pick Dallas because 25% of the time it is warmer, and its median temperature is higher than Nashville. So if we're taking a look at this, these two numbers, how did I get that 25% here? These are really close right here, and this bar is always higher than Nashville. So we could say, again, Lucas should pick Dallas because 25% of the time it is warmer than Nashville, and its median temperature is also higher. Done. Okay, so you always want to use that idea. In both those cases, they're both pretty symmetrically symmetrically distributed. So we can't say that the mean or median would be, or that the mean, sorry, that the median would be a better indicator, but we haven't calculated the mean. So we're just looking at this data, and this is giving us the idea that Dallas is going to be the warmer climate and the most preferred for Lucas. All right, so you're going to try number 2 on your own and then start tonight's homework. I'll be around to help you guys out.